everyone. Thank you for being here today. My name is Nur Fazila Alia and I'm the one of the presenter for our ICT200 final project. Together with my group, we would like to present our project titled Kawaii Bundle Management System. Before we begin, let me introduce my group members. We are from group RCDCS1434D and my teammates are Aisha Liana, Nur Farah Alia, Nur Nazifa Husna and Nur Akila. Each of us has contributed to different parts of this project, from the business analysis to the database design and implementation. Now, let us start with a brief introduction to the company we are working with, which is Kawaii Bundle. Kawaii Bundle, originally known as Kawaii Japan, is a company that operates in the thrift industry. The company was founded in 2019 by Farhad Ikhlas Ventures, and it is located in Jejawi, Aral Perlis. The main business of the company is selling thrift items. Their goal is to become the #1 thrift store in Perlis by offering more clothes categories and a wider variety of thrift items. In the beginning, Kawaii Bundle only used half of the shop for bundle items, while the other half was rented out to the vendors. However, after seeing strong potential and increasing customer interest, the company decided to focus fully on the thrift business. Over the years, it has grown from a small business into a well-known thrift store in the local community. Kawaii Bundle mainly focuses on women's clothing, and it also provides many plus-size options for tops and pants. In order to meet different customer needs, the company serves its customer through retailing, and it focuses on offering a wide range of affordable fashion choices. In terms of daily operations, Kawaii Bundle carries out several routine activities to keep the business running smoothly. This includes daily restocking of clothes to provide fresh selection for customers every day, as well as online marketing through social media platforms to attract more customers. On top of that, the company also manages product sorting, quality checking, live sales session, customer service, and in-store arrangement, all to ensure a better shopping experience for their customers. Because of these daily activities, Kawaii Bundle relies on several types of data to support their operations. This includes product data, inventory data, customer data, sales data, and supplier or stock source data. This data help the company manage their inventory efficiently, improve customer service, and support better business decision making. So that gives you a clear picture of who Kawaii Bundle is and how their business runs on a daily basis.
Hi everyone, I will explain the first question is two SQL statements to create and to eliminate the database. This SQL statement creates a new database named Kawaii Bundle. The database serves as the main storage location for all tables and data related to the system. Next, drop database Kawaii Bundle. This SQL statement permanently deletes the Kawaii Bundle database, including all tables and data stored within it. It is typical use when the database is no longer needed. Let's move to the question B. Okay, for question B, pair of SQL statement to create the table that has relationship to each other in database. The first comment is create table clothing item. This statement creates the clothing item table which store information about clothing products and present the component. And the first, cloth underscore ID, integer primary key, define cloth underscore ID as the unique identifier for each clothing item. Size varchar 10 store the clothing size such as S, M, L or SL. Color varchar 13 stores the color of the item of the clothing item. Price decimal 10,2 stores the product price with 2 decimal places. Supplier underscore ID integer stores the supplier's ID for each clothing item. Foreign key supplier underscore ID, reference supplier bracket supplier underscore ID creates a relationship between the clothing item table and the supplier table, ensuring that every supplier ID exists in the supplier table. Next, we create table restore order. This statement creates the restock order table which stores information about inventory restocking order. Restock underscore ID integer primary key defines restock underscore ID as the unique identifier for each restock order. Status for chapter 18 stores the current status of the restock order, like pending, approved, and complete. Staff underscore ID integer stores the ID of the staff member responsible for the restock order. Foreign key bracket staff underscore ID bracket reference staff bracket staff underscore ID establish a relationship between the restock order table and the staff table. Lastly, we create table order item. This statement creates the order item table which records the clothing item included in each restock order. Cloth underscore ID integers stores the ID of the clothing item. Restock underscore ID integer store the ID of the restock order. Quantity underscore order integer store the quantity of each clothing item order. Primary key bracket close underscore ID restock underscore ID create a composite primary key using both close underscore ID and restock underscore ID, ensuring that clothing item appears only once in a specific restock order. Foreign key cloth underscore ID reference clothing item bracket close underscore ID links the table to the clothing item table. Foreign key bracket restock underscore ID reference restock order bracket restock underscore ID link the table to the restock order table. To summarize, the SQL script are used to create the Kawaii bundle database and its related table. Each table is designed with primary key to uniquely identify records and foreign key to establish relationship between tables. This relationship help maintain data integrity, reduce data redundancy, and ensure consistent and accurate information throughout the database. Okay, next question 3. To SQL statement that lists significant information from a single table in the database. Screenshot the script and the result from your MySQL Workbench or PHP My screen. Next, we select from staff to identify all output. The SQL statement retrieves all records and columns from the staff table. The output display complete staff information including the staff underscore ID, staff underscore name, role, staff underscore contact underscore number, and staff underscore email. Each record represents a staff member together with their role and contact details stored in a database.
I will explain the SQL query that uses a subquery with the in operator. The main query is select from clothing item. This statement displays all columns from the clothing item table. Next, the word supplier ID in class. Check whether the supplier ID in the clothing item table exists in the list of supplier IDs returned by the subquery. The subquery select supplier ID from supplier, retrieve all supplier IDs from the supplier table. As shown in the output, all clothing items with supplier IDs 1, 2, 3, 4, and 5 are displayed because these supplier IDs exist in the table supplier table. Therefore, every clothing item linked to a valid supplier is included in the result. In conclusion, this subquery demonstrates how the imperative and the subquery are used to filter record based on matching values from another table. I explain this SQL query that uses an inner join to fill matching data from two separate tables. This query combines the clothing item and supplier table by matching their supplier ID values. It extracts specific columns like the cloth ID, color, price, and the supplier names. Finally, order by sorts the results alphabetically by the supplier. As shown in the output, clothing items are neatly paired up with their exact suppliers such as bundle per list or classic clothes. Next, SQL query which utilizes a left join to fetch inventory details. This query pulls all records from the primary stock table and matches them with descriptions from the clothing item table using the cloth ID. Because it's a left join, we are guaranteed to see every stock item even if it lacks matching clothing details. As seen in the output, the records are sorted from the lowest stock level at 3 units up to the highest at 40 units. I'll explain this SQL that uses a where clause to filter data by price. The select statement tells the database to display all columns from the clothing item table. The core of the query is the condition where price more than 15. This filters the database ensure we only retrieve items that cost really more than 15. As you can see in the output table, it displays items like the black clothing item at 35 and the blue item at 25, while automatically hiding any item priced at 15 or below. In conclusion, this shows how easily the where clause filters data based on specific numeric criteria.
In this question, we need to write two SQL statements. The first statement uses the in operator and the second statement uses the like operator. The results also need to be displayed in descending order. This SQL statement 1 displays all the records from the cloth item table. The in operator is used to find items with prices 15, 25 or 35. After filtering the data, the order by price DESC command arranges the prices from the highest to the lowest, which is descending order. This SQL statement 2 displays all the records from the staff table. The like operator is used to search for names that end with the letter A, because percentage represents any number of characters before the letter A. Then, order by staff space ID DESC sorts the staff IDs from the highest to the lowest. In this question H, we write two SQL statements using aggregate functions. Aggregate functions perform calculation on data such as finding the total and the average. This SQL statement 1 uses the sum functions to calculate the total amount of all sales in the sales table. The keyword as given the result a new name, which is sum space total space amount. Based on the output, the total sales amount is 500. This SQL statement 2 uses the AVG function to calculate the average price of all items in the clothing item table. The keyword AS renames output as average price. The result shows that the average price is 22.
Hi, I will explain for question I and G. Question I asks for a statement that have relationship using column function having clause. For the first SQL statement, I use the count function together with the having clause to calculate the total number of restock order with the status completed. The count function counts how many records belong to each status. Then the group by clause group the record according to the status such as completed, pending and processing. After grouping the data, the having clause is used to filter the group result and display the only status completed. So, the output shows that there are 3 completed restock order in the database. For the second SQL statement, I use the average function to calculate the average clothing price supplied by each supplier. The group by clause group all clothing items based on the supplier ID. Then, the average function calculates the average price for each supplier. Finally, the having clause filters the group result and only displays supplier whose average clothing price is greater than 13 ringgit. So, the output supplier 1, 2, 4 and 5 has an average clothing price above 13 ringgit. Lastly, question J asks for a subquery. In this example, the inner query calculates the average price for all clothing items using the average function. Select average price from clothing item. After obtaining the average price, the outer query retrieves only the clothing item whose price is greater than average price. So, the output displays all clothing items that are priced above the average, making it easier to identify higher price products. So that's all from us. Bye. Thank you for watching.